Hey, welcome back. So, in our last explainer, we put together this amazing, powerful computer. It had a brain, a heart, a memory, the whole 9 yards. But here's the thing. Imagine that computer is this incredible, advanced island. It's beautiful, it's got everything it needs, but if it can't connect to the rest of the world, it's just a lonely, isolated island. Today, we're building the bridges. We're going to dive into the magic that connects all these islands into one global civilization. The network.
And really, this is the core idea for everything we're going to talk about. Just think about it. Every single computer, every phone, every smart device you own, it's an island. On its own, it's powerful, sure, but it's also limited. The network, that's what lets all these islands trade, talk to each other, and build something much, much bigger. So, let's see how it all works. And that really is the problem, isn't it? It doesn't matter how fast your computer is or how much memory it has. Without a network, it can't share what it knows and it can't learn from anything else. It's totally cut off. Its true potential is basically locked away. So that begs the big question. Why? Why go to all the trouble of building these super complex bridges and sea routes? Why should we connect our islands in the first place? Well, it really boils down to three fundamental reasons. First off, we need to share information. This is the most basic reason. Think of it like sending letters, books, or even treasure maps from one island to another. In our world, every single time you send an email, post a photo, or just load a web page, you're using the network to move information across these digital oceans. Second, we want to share our resources. To save money and effort. Imagine one island has this one giant, super expensive printing press. Now, instead of making every single island by its own, you could just build one bridge and let everyone use it. It's way more efficient, and that's exactly what an office network does with a shared printer. And number three, and this is a big one, to communicate and collaborate, live, in real time. This is what lets the people on one island talk directly to the people on another, work together on the same project, or even, play a game against each other. Anytime you're on a video call or in an online multiplayer match, you're seeing this direct, live link between islands in action. Okay, so we've got the why down. We know why we connect our islands. But what about the how? How does it actually work? What are these connections even made of? Well, it turns out that every network, and I mean every single one, from your Wi-Fi at home to the entire internet, is built from the exact same three essential pieces. It's actually pretty simple. It boils down to this. First, you need the devices. Those are our islands. Then you need a medium. Those are the bridges and the sea routes. And finally, and this is key, you need protocols. Those are the laws that make sure everyone uses the bridges and routes correctly. Let's break each of those down. So let's start with the first one, devices. These are basically the start and end points for any communication. In network speak, you'll hear them called nodes or hosts. And this isn't just your computer or your phone. We're talking about everything from what you might call residential islands, like your laptop, all the way up to huge industrial islands, like the servers that run your favorite websites. Okay, so you've got your islands. Now you need a way to connect them, right? That's the medium. This is the actual infrastructure that links all the devices together. Sometimes it's a real physical bridge, like an Ethernet cable you plug into your computer. Other times it's more like an invisible flight path, like the Wi-Fi signals zipping through the air in your house. Now you might think, okay, devices, bridges, we're done, but not so fast. This third component, protocols, is absolutely critical. I mean, without rules of the road, you'd have total chaos. Ships would be crashing into each other, cargo would get lost. It would be a disaster. Protocols are the laws that prevent all that from happening. So think of these protocols as the official laws of the sea. They decide everything. The standards for what the ships look like, that's the data format, the official language all the ship captains have to speak, who has the right of way in a busy shipping lane. They even handle customs inspections to check for errors in the cargo. And the most famous set of laws, the one that basically runs the whole show, it's called TCP/IP. It's pretty much the constitution of the internet. Now, let's talk about scale, because not all networks are built the same. They can be tiny little private archipelagos, or they can be massive global oceans. On one side, you have a local area network, or a LAN. Think of this like your own personal island chain.
your home or your office, where you own all the bridges yourself. On the other side, you've got the wide area network, a WAN. This is the big map of the global oceans, connecting different cities and countries using public sea routes run by the big telecom companies. And that brings us to the big one, the ultimate WAN, the Internet. The Internet is, quite simply, the largest wide area network on the entire planet. It connects countless smaller networks, which is why you'll often hear it called the most accurate thing of all, a network of networks. And you know, the scale can get even smaller than a LAN. You've also got something called a personal area network, or a PAN. That's what connects, say, your wireless headset to your phone. So this whole idea scales all the way from the gadgets in your pocket right up to the entire globe. All right, let's zoom back out and put it all together. To connect our lonely computer islands, we build networks. They can be small, like a local archipelago called a LAN, or they can be as vast as the global ocean of the Internet, which is a WAN. And every single one of these connections, no matter how big or small, rests on the same three pillars: the devices, the medium that connects them, and the protocols that govern them all. But that leaves us with one final, absolutely huge question. If I send a message from my island all the way to your island, how does the postman know exactly which house, on which street, to deliver it to? How does it find its way? Every single device on the network needs its own unique address. And in our next explainer, we're going to explore that global postal system of the digital world, the IP address. Stay connected.